Okay. Let's go ahead and review one of the applications of a finance application. In this case, would be compounding money, financial application. So, of course, we already went over the compound interest formula. It's periodic. Every n amount of that we apply the interest rate n amount of times in 1 year. If we recall, P stands for present value, A is for the amount or P principal or present value, A stands for the amount in the account or the amount of the account or the future value. 1 plus R is the annual rate, always in decimal. T is time in years, and N is the number of periods in 1 year. So that's the periodic is discrete. But what if we apply the interest rate continuously all the time? That's where the PERT formula comes from. A, the amount equals to P, the principal or the present value, times E raised to the RT, where RT will be the rate in decimal and T in years. So let's go ahead and do a couple of examples. Okay, so this is the formula. Okay, different. They use the, okay, right here, A is P-E-R-T, the PERT, I call it. So let's go ahead and do one example. Okay, right here. Yeah, let's try this one. A person invests, he's a millionaire. He invests $100,000 at 12% compounded continuously. Find the value of the investment after 30 years. That's a juicy investment. We just simply have to plug in the numbers. We just have to remember, first of all, the formula, A equals P-E-R-T. Let me stop sharing. So what do we have now? We have the initial value will be $100,000. That's 1 million. There you go. 100,000. No, 1, 2, 3. There you go. That was correct. 100,000 parentheses. No parentheses. I don't need a parentheses. That would be E raised to the rate was the rate was the rate was 12%, so 0.12 times 30 years. We just plug it in like that. If we were to look for the calculator, just punching everything in the calculator. Let's go ahead and share this. Come on. What do I have here? The calculator, where are you? The screen with the calculator. Okay, so this is what we have. My $100,000, then I do second ln, that will give me E raised to what? 0.12 times 30 years. Equal, that would be a juicy amount. So that's what, 1, 2, 3, that's 3,659,823.44. And that's it, just plug in the numbers. Okay, so let's go ahead and do another example. I need to make the noise, it will find me anyway. So let's go ahead and look for another example, folks, so we can wrap it up. Sorry, should I? Number 42 will be exactly the same thing as we did before. In this case, number 42, hopefully you can see it. That will be, we're going to invest $12,000 at what percent? At 0.072. 7.2%, 0.072 over how many years? 30 years times 30. So we can calculate that one. There's another one that I wanted to do. Okay, so let's go ahead and look at this one, number 65. Jamal wants to save $54,000. So now his goal is 54,000. How much he needs to save now? So we're solving for P. Here it says compounding daily. Let me assume that it says compounded continuously. So I don't get you dizzy looking for the right problem. So 54,000. How much money I need to invest now if the investment is at 8.2% continuously compounded? So it will be E to the what? 0.082 T. Over how many years? No, 5 years times 5. Times 5. Okay, so let's go ahead and work on these ones. Let me stop sharing the document so I can share the calculator. Share the whole thing. Okay, so this is what we have. Look at this. So of course, it's simply my $12,000. That's my seed money initial investment. 12, 1.3. Second E. Notice that I'm solving for A. So I take my $12,000 times this chunk, which is E to the 0.072 times 30. And of course, the final amount after 30 years will be 104, 1 million. 1,040,000. No, I was right. Oh my God, I need new glasses. So it's 104, I was correct. It was 104, 053.65. Okay, so this is how much my money will grow from $12,000 to 104,000 at 7.2% over 30 years. Now, Jamal, in this other example, he would like to have $54,000 in 5 years at 8.2%. How much money he needs to invest now? Now, we know A, we need to solve for P. On the previous example, we knew P, present value, we needed to solve for future value. So of course here we don't multiply, we just simply take my 54,000 and we divide by E raised to that so we can solve for P. So how much is this one? Is going to be the future value is 54,000 divided by second E raised to the 0.082 times 5. So Jamal has to invest approximately $35,000, 37.11. Yeah. So knowing, so let's recap. We knew the present value, we knew the rate, we knew the time, so we solve for future value. Second example, we have a goal of future value. Knowing the percent and the time, we solve for how much money we need to invest now. What if I want to ask you, well, let's say, how long would take an investment to double in time if we invest the money at 9% continuously compounded? Okay, so we want to double the investment. Okay, so since it's continuously compounded, the formula is, this is very starting me now. So it's A equals, of course, the PERT formula. Now, if you want, you can use any number. Sometimes my students use $10, so therefore double would be 20. $100, double would be 200, obviously. $1, which is the obvious number to use, then it will be 2. One time I use 1 cent, how much I need to wait for to get my second penny. So anyway, so of course, if I start with $1, I need, of course, to get $2 to double my investment. E to the RT, we say 9%, so it'll be 0.09, and we are solving for T. Okay. So notice here, folks, that I don't have to divide because 1 is 1, so I can just even erase it. And now how do I solve this one? Okay, so let's continue. So anyway, so what is the goal? The goal is to double the investment if continuously compounded at 9%. Since it's continuously compounded, of course, we use the PERT formula. And as I was saying before, we could use any investment. If I invest $10, double will be 20. If I invest 1 penny, 2 pennies, 1 million, 2 billion, $1, $2 will be the obvious one to use. So notice, of course, that we can erase the 1. We don't need it. And I just rewrote it the other way around, that way you are more comfortable. So now what do we have? E raised to the 0.09 t equals 2. So we just ended up with an exponential equation. And we know that in exponential, we change to log. In this case, it has to be log base E, namely ln of what? ln of 2 equals 0.09 t. Since I'm solving for t, therefore t equals ln of 2 divided by 0.09. Yeah, we can just punch it in the calculator to see how much is that. So ln of 2 over 0.09. Let's go ahead and do this. Okay, let's see what we have. ln of 2 parentheses divided by 0.09 equals 7.7. 7.7, that would be good. So of course, when we use the calculator, it gave us 7.7 years, just about. And that would be it. So yes, if I start with 1 penny, I would need 7 years, almost 8 years to get my second penny. That's painful. Anyways, you will notice, students, if you do the following, what if they ask us 12%? It will be ln of 2 over 0.12. Okay, if it's 15%, ln of 2 over 0.15. If they ask us how long it takes to triple the investment, it will be ln of 3 over the interest rate. So triple the amount, ln of 3 over the interest in decimal, of course. Over the interest in decimal. If we want to double, it will be ln of 2 over the interest, as long as we are doing it continuously compounded. So that's all I wanted to show you. Given continuously compounded, given the P, present value, how to solve, how to look for the future. We did a couple of examples of those. Given the goal or the future, how much I need to invest now. And the last but not least, knowing the present and the future, solving for time. And of course, when we solve for time, we end up with the exponential equation, so we just switch to logarithm. Thank you.